students, this is the third video of fundamentals of counting theory. In this fundamentals of counting theory, we have first studied about rule of sum and rule of product. Now we are moving on to the next topic, permutation. So what is permutation means? You have to know first the definition, then how many types or how you can arrange the objects you have to know. A permutation is an arrangement of objects in a definite order taken some or all at a time. That means we hear one thing, in permutation ordering is important, or when you arrange an object or when you have to arrange an object, here mainly you have to verify that ordering is important. So you have to check whether the ordering process or arranging the process should be important. So a permutation is an arrangement of objects in a definite order. You have to arrange the objects in a definite order, in a particular order, taken some or all at a time. Sometimes if you have many objects and some options are given for you and you have to arrange some of the objects, maybe sometimes all the objects you have to arrange, or sometimes you have to arrange some objects. So such cases also, if it is some or all at a time, in any of the cases the arrangement is important. A permutation is an arrangement. That arrangement is very, very important in a particular order. So the next one is the permutations when the objects are distinct. That means if the repetition is not allowed. There is a theorem statement, you may have heard about it. The number of permutations of n different objects taken are at a time. So some objects are there, so n different objects are there, and also see objects are distinct. That means repetition is not allowed. So if the objects are distinct means you remember that repetition is not allowed. So remember that repetition is not allowed here. If the objects are not distinct, then you can say repetition is allowed. So there is a statement, the number of permutations of n different objects taken are at a time where 0 less than r less than or equal to n, maybe where r is less than the total number of objects, maybe it is equal to the total number of objects or maybe less than the number of objects, but it should be greater than 0, and the objects do not repeat. That is NPR. That means the permutation is denoted by the symbol. That means arrangement of objects in a definite order taking some or all at a time. It is called as permutation. It is denoted by the symbol NPR, which means that there is a formula n factorial divided by n minus r factorial. So this is the formula for NPR, that means permutation. So you all know that. Now coming on to the second case, permutations when repetitions are allowed. If repetitions are allowed, then the rule of product is applied here. If repetitions are allowed, then by the rule of product we can say the number of possible arrangements are n raised to r. That means if all the objects are repeated, then we can say that it is n raised to r. So remember that if the objects are distinct, then the formula is NPR. If the objects are, remember that if the objects are distinct, if it is if the objects are distinct, then the permutation formula is NPR, and if the objects are not distinct, then we can say that the formula is n raised to r, where r is always greater than or equal to 0. Now comes the third case. So this is the second case. Now comes the moving on to the third case, you will be having an option that the number of distinguishable permutations of n objects. So if you are having some objects are distinct and some are not distinct. Suppose where one object is repeated n1 times, another object is repeated n2 times. That means one object is having repetition n1 times, second object is having n2 times repetition. Then the number of arrangements are number of possible arrangements. So here remember that this is number of possible arrangements. The number of possible arrangements are n factorial by n1 factorial into n2 factorial into etc. up to nr factorial. N factorial by n1 factorial, n2 factorial, etc. nr factorial. So these are the three types of this first definitions and three types of categories are there. Let me explain these definitions or these properties along with an example. So first of all, let us consider three letters A, B and C. And then how much arrangements are possible? First choice, if the repetition is not allowed, that means the objects are distinct. If the repetition is not allowed, means here the objects are distinct. Remember that here the objects are distinct. Now if the repetitions are not or allowed, if the objects are repetition is allowed, means the objects are similar. That means there are two categories it is there. Now let us consider the positions to be A, B, and let us consider the letters to be A, B and C. So how many positions are there? We have to compulsorily we have to fill the first position, second position and the third position. So first position we have to fill. We are having how many options in hand? You will be having an option of A, B and C is there. So the first position, so you are having three choice of letters. That means the first position can be filled in how many ways? That is three ways. Why it is three ways? That means you are having in three choice of letters. That means out of the three you select one of the letter. Out of the three we select one of the letter. So this is here the condition is repetition. Remember that repetition is not allowed. So here if the repetition is not allowed, then once when you fill a column with a single letter, that letter is not repeated again in the further columns. So first if I take A, B and C, then I can say the first position can be filled in three ways. That means out of the three I can select one letter. Now next column, after filling the first position I have to fill the second column also. So if I want to fill, that is necessary. That means first also I have to complete, second also I have to complete and the third position also I have to complete. That means all the events has to happen simultaneously, which means I have to apply the rule of product. If I want to apply the rule of product, not rule of sum is not product because either any one of them is not asked here. It is asked all the three events has to happen simultaneously. So the first position has to be filled in three ways. Now how many letters are left over? Because when you take a letter in the first position, that is not repeated in the second position. So the second position you are having how many letters? So we are having three letters. Now one of the letter I have taken here. So remaining you are having two letters. So remaining you are having two letters. Remember that you are having two letters. So if you are having two letters, out of the two you have to select one of the letter. That means out of the two you have to select one of the letter. Now at last you are left over with one, because first position I have taken a letter which is not repeated in the second also. Now when I come to the third position, first letter and second letter is not possible to fill in the third position. So I am left over with only one letter, that is only one letter. So I am having only one option. So therefore since repetition is not allowed here, the third position can be filled in one way. Therefore, by using the rule of product, all the three events has to happen simultaneously. Therefore, the total number of possible arrangements are, this is equal to 3C1 and 2C1 and 1C1. So 3C1 means 3 and denote into the product 3 into 2 into 1, that is equal to 6 ways is the answer. Now, coming on to the second part, if the repetition is allowed here, I'm having how many letters here? 3 letters. So, as usual, by the rule of product, I can say the first position can be filled in 3 ways. Now, once I fill a column with a single letter, that letter can be repeated in the second position also. I can fill either the first letter or any other different letter. Remember that the second position can be filled in how many ways? 3 ways. Why it is 3 ways? Because the first position has 3 letters. That letter, for example, if I am taking here, it is A. If I am taking as A, means in the second position I can fill either A or B or C. I can fill. Therefore, I am having how many options here? 3. So A can be repeated here also. Now coming to the third position. So I have to fill the first column and I have to fill the second column and I have to fill the third column also. When I come to the third position, I have to complete check whether how many letters. So here also I can repeat the same letter in the first position, or I can repeat the same letter in the second position, or I can write a new letter. Whatever it is. Now here also I am having an option of A, B and C. So therefore the first column can be filled in 3 ways, second position has to be filled in 3 ways, and the third position has to be filled in 3 ways. Therefore by the rule of product, the number of possible arrangements are, so there is a formula. If repetition is allowed, then the formula is n raised to r. So that means which denotes that 3 into 3 into 3, because from here itself it is clear that the answer is 3 into 3 into 3. Therefore 3 raised to 3, or in short you can write it as n raised to r, that is equal to 27 ways. This is the second part. That's all. Now next question. In a class of 10 students, five are selected and seated in a row for a picture. How many such linear arrangements are possible? Suppose if I have in a class of 10 students is there, you just leave this sentences. I have written a sentence that you doesn't bother about that. Here, see, listen here. In a class of 10 students are there. That means it is here given that 5 are to be chosen and seated in a row for a picture. So 5 has to be selected and has to be seated in a row for a picture. That means 10 letters are there. We consider the position and the number of students we can choose from in order to fill each position. That means the first position can be filled in how many ways? You are having 10 students, so 10 options are there. That means our first position has to be filled in 10 ways. So here it is 10. So out of the 10 we select 1. So now 1 is left over. Now remaining I'm having, because here we are not allowing, because out of the 10 students we select 5 students. That means the second position has to be filled. So first we are not going to place the first person. We are not allowing the first person. It is not possible for a person to be seated in the first and second position. Remember that when you place a position, that means in the first position if I place a person, then he is not allowed to sit in the second position. He can't sit in the first and the second position. That means the second, now you are left over with 9 students. So now out of the 9 I have to select 1. So second position can be filled in 9 ways. And the third position, now coming to the third position, now remaining 8 letters, remaining you are having 8 students. So out of the 8 you have to select how many? 1. So 8C1, here also 9C1, here 10C1. So now at last, fourth position, you are left over with 7 students. So out of the 7 you select 1, and at last the fifth position you are left over with 6 students. So out of the 6 you select 1. Therefore the answer is 10 into, so first one I have to fill all the 5 seats. So therefore first position and the second position, this is and second position and third position and fourth position and fifth position, that is equal to 10 into 9 into 8 into 7 into 6, that is equal to 30,240 arrangements of 5 students selected from the class of 10 students. Now listen here. The number of permutations, there is another example, the number of permutations of a letter in the word computer. So in a word computer, how many letters are here? C-O-M, computer, C-O-M-P-U-T-E-R. That means N is equal to 8. The letters are distinct. All the letters are distinct. That means, how can I write this? I can write as the first position can be filled in how many ways? The first position can be filled. See, listen here. I'll write the answer here. So 8 positions are here. Number of possible arrangements is equal to, I'm taking the number of possible arrangements. So the number of possible arrangements are, I can take as the first position has to be filled in 8 ways. Then see, listen here, I'm having 8 positions. So I'm 1, 2, 3, 4, 5, 6, 7, 8. So I have to fill here. First position has to be filled in 8 ways. Now 1 is left over because all the letters are distinct. So C, O can be filled in how many ways? Now remaining I am left over. C is over. C I have taken. Now I am left over with 7 letters. So 7 into 6 into 5 into 4 into 3 into 2 into 1, that is equal to, so I can write this as 8 into 7 into, so how many positions? 3, 6, 8 positions. 8 positions can be filled in this phase. That is, in short, I can write it as 8 factorial. If all the letters are distinct, means here repetition is not allowed. Repetition is not possible, which means that I can write 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That is equal to 8 factorial. So therefore, you can write the answer as 8 factorial, so that you write it. So next one is, if suppose I am asking you to arrange out of this 8 distinct letters. So here you are having 8 distinct letters. Out of this 8 distinct letters, you have to select 5, or you have to select or arrange 5. You can write it as arranging. Let me take it as arrange. So you have to arrange 5 letters. How will you arrange 5 letters? So here I am having 8 letters. Out of this I have to arrange 5 letters. So therefore it is denoted by the symbol 8p5 or NPR. That is equal to, you know that, n factorial by n minus r factorial. That is 8 factorial by 8 minus 5 factorial. That is equal to 8 factorial divided by 3 factorial. So this can be written as 8 into 7 into, you can write like this, 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 by 3 factorial can be written as 3 into 2 into 1. So this 3 into 2 into 1 gets cancelled. So remaining, when you multiply, you will get an answer of 6720. Now, next one, see, listen here. If the repetition is allowed, see, if the repetitions are allowed, then by the rule of product, how many possibilities are here? N raised to r possibility. Now, next I'll give an example. Let us consider an example as for the letter ball, B-A-L-L, ball. So can you say that the letters are distinct? Because in the previous example, computer is distinct, but here BALL is not distinct. So I can't say that the permutation answer is 4 factorial, because n is here, n is equal to 4, and I can't say that 4 factorial because there, what is the reason? That we do not have 4 distinct letters. But in the previous problem, see, in the previous problem, computer, when you take computer, all the 8 letters are distinct. So you can say directly the answer is equal to 8 factorial. But here it is not possible because BALL is repeating. See here. So you are having a word of BALL. So B is repeated only one time. A is repeated one time. L. So how many times? 2 times. So some letters are distinct, some are distinct, and one of the letter is repeating, which means that here the permutation formula, that is the NPR or P of n comma r, the number of permutations, P of n comma r can be given as how many letters? 4, n equal to 4. That means the number of permutations or number of possible arrangements are, that is equal to 4 the formula is n factorial divided by n1 factorial into n2 factorial into n3 factorial. So here n is equal to how much? N is equal to 4. So 4 divided by n1 factorial, that is, see, listen here, let us take n1 equal to 1, n2 equal to 1, and n3 equal to 2. See, n1, n2, n3. So therefore here it becomes 1 factorial into 1 factorial into 2 factorial. 2 factorial. So that is equal to 4 factorial divided by 2 factorial, which is equal to, I can write it as 4 into 3, that is equal to 12 arrangements. Now, considering another arrangement of the 6 letters, so another word is given here. Can see here, there is another example, pepper, P-E-P-P-E-R. So here, see, P-E-P-P-E-R. I'm writing like this. First letter P. Now E. Next letter. Now again P. So I'm writing below this P. Again P. Now I'm writing here. Again E. Right below E. Now R. That means how many times? 3, 2, 1. Let us take first. So some letters are repeating, some letters are not repeating. So number of distinct letters are how many distinct letters here? 3 distinct letters. That is P, E and R. So therefore the number of permutations of the letter is equal to n factorial divided by n1 factorial into n2 factorial into n3 factorial. So now n1 factorial is equal to, what is n factorial? N equal to total number of letters. N is equal to P-E-P-P-E-R. That means n is equal to 6. So 6 factorial divided by n1 factorial. What is n1 here? See, n1 is equal to, let us take here, n1 is equal to 3, n2 is equal to 2 and n3 equal to 1. So here on substituting, here you will get 3 factorial into 2 factorial into 1 factorial. That is equal to 6 factorial. You can use the calculator also. You can directly use the calculator and find the answer, which is equal to 60 ways. Or if you are not using the calculator, you can write it as 6 factorial can be written as 6 into 5 into 4 into 3 into 2 into 1 divided by 3 factorial can be written as 3 into 2 into 1 into 2 factorial can be written as 2 into 1 into 1. So 3 into 2 is, see, 3 into 2 into 1, here also 3 into 2 into 1. So now here 2 and this 4 gets cancelled. So 6 into 5 into 2, that is equal to 60 ways. You can write in this way, or you can use your calculator. Use your calculator and find the answer very easily. Now, consider a new word, Masasuga. Now, in this word, how many distinct letters are here? How many distinct letters? 10 letters. So, therefore, I have totally 10 letters. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters are there. Therefore, the possible arrangements. See, M is 1 time, A 1 time, S, again S, again A, so right here, again S, right here, again A, right here, U, another word, G, another word, again A. So how many letters here? M 1 time, A 4 time, S 3 times, U 1 time, G 1 time. That is, the formula for this number of possible arrangement is n factorial divided by n1 factorial into n2 factorial into n3 factorial into n4 factorial. That is equal to 10 factorial divided by We'll be having n1 is 4. First one is, you can write it as, see, listen here. First one, how much letters? 1 factorial into a, how many times? 4 times. Now s 3 times, so 3 factorial, u 1 time, g 1 time, so 1 factorial. So use the calculator, it is better. You can find the answer, that is equal to 25,200 pace or here. Okay.